I am Prasanna, who is an Associate Technical Lead at WSO2. I welcome all of you to our third session in our API Manager community call. Previously, we had two community call sessions and we got some queries from the audience. Hence, we thought of mainly focusing on those queries in this session. The main query came regarding the monetization. So first of all, let me describe what is monetization for those who doesn't have an idea about monetization. So monetization is engaging a billing plan for WSO2 or whatever the API manager solutions to calculate a bill with respect to the API calls that will be invoking. So in the one of the last sessions, we got a question that how can we combine two billing plans actually. First of the initial one was to have a fixed billing plan up to a certain limit, and after that limit increase the API call value and calculate the bill. As an example, let's assume a plan which cost $500 for the first 5,000 calls and 2 cents per any call after that during that period. Let's assume a month. So yes, we can achieve this with a custom implementation. Let's discuss how we can achieve this. From the administrator UI, when you are creating a subscription plan or when you are updating a subscription plan, first of all, you have to untick the stop on quota reach tick. And I'll explain how you can achieve this using the Stripe billing engine. In Stripe billing engine, there should be 3 custom parameters that we need to supply for them to achieve this requirement. The parameters are billing schema, tier mode, and tiers. Billing schema should be set as tiers. Tier modes should be set as graduated, and tiers should be set as the diagram that I have shown here. You can add multiple tiers. So in the JSON that I have showed in the right slide, it has a flat amount of 5,000 requests. Flat amount means you get 5,000 requests and you will be charged for that 5,000 requests, even though if you get 1 or 2. And after you achieve the 5,000 request mark, if you go to 5,002 requests, then the other 2 will be calculated with 2 into 20 cents. So once you pass these custom parameters through the admin UI, you have to extend or customize the Stripe monetization implementation. And in the implementation, you have to modify the create billing plan and update billing plan methods. So I have shown you onto your right of the slide how you can achieve these custom parameters to the back. So now you are capable of sending these custom parameters from API Manager admin UI to the backend implementation. Now the required part is to send this to the Stripe billing plan. So let's move on to that. And I have shown the Java code onto your right that you have to send, right? So you have to customize the implementation and get this done. So the billing engine, the Stripe billing engine is responsible for calculating the bill. So since we are sending the usage along with respect to the timestamp, the Stripe billing engine will calculate the bill with respect to this plan. So this was the first question that we got. And the other question that we got was API Manager best practices for deployment patterns on different infrastructure such as VMs and containers. So my colleague Dinusha will conduct this session. Over to you, Dinusha.
Thank you, Prasanna. I hope everyone can hear. So I'll begin with a short introduction about deployment. So shall we move to the slide? Okay. So basically there are two deployment types. One is active-active, which consists of 2 or more all-in-one node, as you can see on the left diagram. And the other one is distributed deployment type, where each node contains a single or subset of API manager profiles. If you could see the diagram on your right, you can see an example. So based on these deployment types, there are five predefined recommended deployment patterns to cater to different requirements. As you can see, pattern one is can be used when you are working with low throughput, whereas pattern two can be used when you have higher throughput with lower token lifespan. Similarly, you can use pattern three for higher maintainability at each layer with high flexibility in each component. And if you have to handle external traffic and internal traffic in different gateways, then you can use our pattern 4 and pattern 5 deployment patterns. These deployment patterns can be deployed either on virtual machines or in the containerized environments such as Docker, Kubernetes, Openshift. Whatever the pattern you follow, there are some common best practices you have to adhere in each deployment infrastructure. Let's move to the next slide. In VM mode, the important thing you need to consider is content synchronization. For example, we need to synchronize Synapse artifacts across gateway nodes. And we need to sync execution plans related to throttling policies across traffic manager nodes. For this, the recommended approach is to use a shared file system such as NFS. As an alternative, we suggest rsync in case you are unable to use NFS. Since rsync is one-way synchronization mechanism, it can cause a single point of failure. Because of that, the recommended approach would be a shared file system such as NFS. Now let's move to the next slide to talk about containerized mode. In containerized mode, you have to consider a few facts. The first fact is to maintain images on your private Docker repository. You can pull the WSO2 API Manager related images from WSO2 repository. You can use these images as the base image and create your own Docker images by including the customization you have, such as custom jars, themes, etc., and build your own image and push into your private repositories. The second fact is content synchronization. This is the same as what we talked in VM mode. We have to use a shared file system such as NFS in containerized environments as well. And we have to use volume mounts to persist data in Solr directory and the H2 databases. The Solr directory contains the frequently used API metadata to make API search faster in API Store and API Publisher. And also H2 databases are used to keep the node specific details and some the data in the file system. So this data needs to be persisted. Hence, for this, we have to use volume mounts. The other important factor is key store and trust store. So if you are using a functionalities where you will be adding certificates to the client trust store dynamically, then you would need to use a volume mount. But if you do not want to add certificates dynamically to the client trust store, there are two methods that you can follow. One is in a Kubernetes-like environment, you can use Kubernetes secrets config maps as key stores and trust store, and you can mount them into the containers. Or else you can create your own key stores and trust store and trust stores, and you can following the fact that I mentioned in first point, you can burn those into the Docker image, and you can maintain on your own image. So that's basically everything from me, a basic introduction on best practices regarding deployment patterns. Prasanna, over to you.
Thank you, Dinusha. So the other question that we got was about the challenges in a multi-DC deployment. I hand over this to my colleague Bhatia to address this issue.
Right. Thank you, Prasanna. Yeah, when it comes to multi-data center deployments, one of the main challenges that we face is that keeping data consistent across data centers. So if you think about WSO2 API Manager, so we have two types of data. So one, the one we save in file system, the other in the database. So like Dinusha mentioned earlier, our recommendation for sharing file files stored in file system is the network file system. If you think about the data stored in the databases, we need to think of how to sync this data across multiple data centers. For that, there are certain tools you can use, such as Oracle Golden Gate. Oracle Golden Gate supports certain databases such as Oracle, MySQL, MS SQL. So in a minute, I will talk about what are the challenges and solutions that we should take. So if you think about API Manager, if you look at this slide, we have two types of components in API Manager. One is runtime components, which includes gateway, key manager, and traffic manager, etc. And then we have design time components, such as publisher and dev portal. So usually in a typical deployment, so it is required to have these runtime components in the active manner. That's because we get a lot of traffic into these runtime components. But for the design time component, the story is a bit different. They don't get a lot of traffic. Therefore, it's okay to have them in active passive manner. On the other hand, when it comes to a multi-data center deployment, where we want to sync database data, it's a bit hard to achieve data syncing for design time components in the two-way manner. Therefore, we are going with active passive mode for the design time component. So like I said, you need to use a tool like Oracle Golden Gate to sync data between data centers. For that, to use those tools, you need to fulfill certain requirements. Mostly those requirements are script level changes. I have listed down a few such things. The first one is you need to have unique or primary key for every table. In our default database scripts, we do not have this. Therefore, in API Manager 3.1 onwards, we are shipping a separate database scripts for data center deployments. In those scripts, we have handled all these cases I'm talking about in this slide. So there we have added unique or primary key for all those tables. And then we have to handle all auto increment columns. We have to handle auto increment columns. There are three main ways to handle that. Why we need to handle auto increment columns is that otherwise it can create conflicts between the syncing process. Because if two nodes increment this to the same number, when it tries to sync, it can create conflicts. Therefore, we need to avoid those conflicts. There are different ways you can do that. So one way is having not specific sequence range. That means if you have two different theses, we specify one range to one node. For example, assign 1 to 10,000 for the first data center and 10,001 to 20,000 to the second data center, etc. The problem with that approach is someday the auto increment value can reach the limit of that range. So we have that problem with that approach. And another approach is using a common sequence. So what happens there is we keep a common sequence and each data center calls that common sequence to get the next incremented number. The problem with this approach is these data centers had to do a network call, so which can add some latency to the database operations. Another one is the start value variation. That means we assign a starting value for each of these each of these data centers. For example, if we have 3 data centers, we assign 1 for the first one, 2 for the second one, and 3 for the third one. And all 3 data centers increment their values by 3. So then the sequence of the first node becomes 1, 4, 7, 10, etc. And sequence for the second one becomes 2, 5, 8, 11, etc. And for the third one, it becomes 3, 6, 9, 12, likewise. So that way we can avoid conflicts. And another problem is handling cascade operations, because cascade operations can conflict with database replication process. Therefore, we have to avoid cascade operations in a multi-data center deployment. So we can do that with triggers. Simply what we do is we replace cascades with triggers. So we have done all of these in our multi-data center database script, which we ship with 301 release. So that's it basically. So we are actually working on an article with all this information, describing all this in detail. So we are planning to publish that within next couple of weeks. Yeah, so that's it from me.
Okay, thank you, Bhatia. So the other question that we got was about how to configure open tracing with Jaeger. My colleague Taridu will address this issue.
Thanks, Prasanna. Yeah. So if I give a brief description on the open tracing, what was done in the API management. So the API management can connect into the multiple services, and that API manager can have connections from the multiple clients and things. So in that case, that users need to know from which point to which point where does this the request has been goes on. So if you have the open tracing implemented on your clients and services, then you can streamline the request from the open tracing where it goes. So from the API management concept, like we had introduced the open tracing information as the API name and version, and then the what was the endpoint that's going to invoke, and then the time taken to each of the process, like how much time it's taken to the course, and how much time it takes to the validating token, and that kind of things. Yeah. We had 3 different types of traces available in the WSO2 API management. The first one is Jaeger. So from Jaeger, you can configure into the Jaeger and get the information from the Jaeger directly, and Shipkin and the log tracer. So the log tracer is the one that you can log the tracing information into the logs. So that was creating a log file in the logs directory with the open tracing .log. So in order to configure specifically with Jaeger with the API manager, so you need to open the TOML, and then you have to put the section like this, like the apm.opentracer, and then you need to enable the remote tracer, and then the remote trace type is Jaeger, and then the host name and the port. And so if you need to enable the log tracer, then you have to put the log tracer enable and make it start. So once you enable it, and once you make the requests, so you will be able to see the following information, like, yeah, let's move to the next. I was not. If you could see, so these are the information that got captured in the Jaeger. Like in the first one, you can see that API latency. That was the WSO2 API Manager service in the Jaeger, and the backend one. So that is the backend that is used to invoke by the API Manager, and the client who is the invoke the WSO2 API Manager. So if you drill down that first one, yeah, let's move to the next. Yeah, once you drill down that one, you can see that client has been executed the request, and you could see. So I was used as the Spring Boot application. So you can see that it has the information like where does it get invoked, and what was the port, and what was the HTTP method. So so if I go through that one, like you can see under the API latency, you can see the course request handler, and the API key validation latency, and the throttling latency, and that kind of lot more information. And then once after that, you can see there was a yellow color one called backend. So the backend is the one that was get invoked by the API manager. So in that place, you can see what are the tags that got invoked, like that is 82, 80, and the HTTP method as get. Yeah, let's move to the next person. So you can see, so what are the information got captured in the tags. So like we can see the activity ID. So the activity ID is the one that you can send through the request from the different service. Like if you send a header like called activity ID, then it got captured. Or if you're not sending that kind of one, so then we got captured like there was a message ID called in the Synapse world. So we got captured that one. So in the API name, so what was the API that got invoked, and then the version, and the consumer key that got generated the access token, and then what are the request method, and then the request path and the resources. So these are the information that got captured. So I think this got to clarify what are the information that was needed by the open tracing environment. Yeah, Prasanna, over to you.
Thank you, Dinusha. So now we are open for the open discussion session.
Yeah, it's regarding parameterizing the Trusto and Keysto. So what I can see from the document is I have to copy the new, like, even though I can set that as an environment variable, I'm talking about deploying it on Kubernetes or Openshift. So I have to copy those new Trusto and Keysto inside the repository resources security folder, right? So that's what the 3.0 document says. So in that case, like I can't create a new config map or something like that and mount it, right? Is it?
Yes, you can use a secret with the key stores and then mount it to the deployment.
So let's say my cluster is already running. So if I want to change my key store.
So it is like you want to change it. Basically, these are not changing very frequently. So this could be a one-time task, or maybe you change it after 5 years or like that. Is it something you are changing your certificate? You are dynamically adding certificate, or?
Yes, something like let's say so if I want to parameterize that, parameterizing means using the environment variable. So is it like mounting that one into repository resource as security, creating a config map to mount it to that place and changing it?
Yes. So is it like you have environment wise key stores?
Yes, there is a possibility of that.
Yeah. So then you can have key stores in a secret and then mount that to the deployment. That's one option. Or else you can have you can burn those into the image itself. So
Yeah,
then
if I burn it to the image, while deploying it, I can't change it, right? So if I
no.
pass it as an environment variable, then only I have the option to change it. Am I correct? Or am I missing
Yes.
something?
So if it is like if you are creating multiple images per environment kind of a way, then that can be done. Otherwise, you can have to use secrets.
Yes, we are not creating multiple images. So,
Okay.
so every environment, they can have different certificates. So, so in that case,
Okay, then the option is to like you have environment wide secrets, then that secret is being used in the deployment.
okay, okay. So that's something I can do with config map and mounting that one later. And
Yeah, so I
create
think
the
it's
environment
better to
variable.
use a secret rather than using a config map, because key stores are somewhat
You are
secure.
saying about the Kubernetes
Kubernetes.
secure
Yes.
vault feature, right? So
Yes.
the Kubernetes version we are in is pretty old, so we don't have that feature. So
Okay.
it's, yeah, so we have to somehow stick to config maps. So what I'm thinking is correct, right? Then config map and
Yeah, so
mounting it.
but what I know is like in older versions there is a issue in when you use a config map to use a JKS file, so it corrupt when you mount it. So that issue is being solved in the latest versions. So if that issue persists in your version, I think other option only available is to have
Multiple
burning
images.
image. Yeah.
Yeah. Okay, that's good to know. Yeah, I will try that. Thank you. Thank you, Prabhuda.
Okay.
Okay. So, do we have any other questions?
Hi, hello.
Hi.
I was trying the Jaeger open tracing feature from the release candidate 2 from yesterday. And that's great, guys. Thank you. And I can see the part where you show that set the client. Only I can see the API latency service, but can't see the client where you show that you have all the tags related to the API name version. I can see it. I'm trying this using the Pizza Shack API, and only can see the API latency, not the client thing.
Okay. So we got the question. I think Tarik will ask the question for you.
Yeah. So in the RC2, we had some the issues in the push these changes into the open
Okay.
jaeger. So that was get fixed in the next RC. So probably on tomorrow.
Okay. Okay.
So
Thank you.
that information we will be able to see after that.
Okay. Thank you. Another question about the deployment. If you are using
so that you can try.
Sorry.
Okay, you continue. Okay.
Okay. Another question related to the deployment with Kubernetes or OpenShift. The scaling feature, where in how to use it? Because if you deploy an all-in-one, it's okay to scale all the all-in-one deployment?
Hi. So no, we don't recommend to scale all in one because so the scaling profiles what we normally say is gateway and key manager. So other than that, we don't recommend other. So there is no requirement to scale other components or the profiles. So if you want to go with the scaling option, then maybe you have to go with pattern 2 or 3 that have gateways separately, but pattern 1 or 2 node HA pattern, you cannot do the scaling.
Okay. Thank you.
Okay, so now we are concluding this session 3 of our community call. So we are having this bi-weekly. So our next community call is on April 1st, 2020 at the same time. So if you have questions, please feel free to add these to this form link, and you can use our Slack channel to ask questions and dev channel, dev email address as well. So please feel free to ask questions in Slack. Please join our API Manager Slack channel, and we will see you in 2 weeks' time. Thank you.
Thank you, guys.
Okay.
Thank you, guys.
Bye.
Bye.